Hey, how's it going? I figured I'd have a bit of fun today. Some people do get ready with me's, so this is plan my master's degree with me. As you may have seen in one of my previous videos, I sort of wrapped things up on a Bachelor of Maths actually, but it was a Bachelor of Maths where I honestly haven't done maths in a while, and I was just loading on as much computer science as I could towards the end of it. But anyway, things are wrapped up now, and I debated whether to just spend some time, work and develop the game. But at the end of the day, there's so much cool stuff. You're saying, hey, do you want to study this stuff? I'm like, yeah, I want to study this stuff. So I figured I'd bring up the curriculum and we'd have a look through it, and then I'll talk through what I'm doing. So in terms of duration, I'm going with the 1.5-year program. I'll be doing that part-time because I need to pay bills, basically. So we'll be looking at 3 years, not that it matters, it'll still be the same amount of study. Now, at UQ, you do basically 4 subjects a semester. Every subject is worth 2 units. It's a little strange, and the reason for that is there are some smaller subjects which are only worth 1 unit, but they're very, very rare. But anyway, so just bearing in mind 2 units per subject. Okay, I think the sound's mostly gone. Look, what I do when I record these videos sometimes is I open up the windows to get some nice breeze through because it's Australia. But the downside to that is if there's any traffic, it'll go bonkers, and there's a garbage bin going past at the moment. But okay, so here's the program. So it's 1.5 years full-time, which would be 12 subjects, we could say, 4 subjects per semester. And we have these sort of components that it breaks down into. So we have core courses. There's always a research project of some sort. Then we have undergraduate electives, and then postgraduate electives. So I guess we'll start with the undergraduate electives, and what I'll try to do is open these all up and sort of step through them. And as I do this, you try to guess what I'm doing. Okay, so to start with, we have operating systems architecture. As we can see here, we're working on basically like what operating systems are and how they work. But yeah, as it says here, we're also doing some advanced kernel level and device driver programming techniques. Algorithms and data structures. It's pretty much your standard algorithms and data structures course. So you've got your linked lists, your arrays, hash tables, binary trees, all of that sort of stuff. Artificial intelligence. Now, this one is mostly classic artificial intelligence, so basically dynamic programming, greedy search, heuristics, that sort of stuff. But there is some, I think there is some sort of modern artificial intelligence towards the end of it. Computer Networks 1, which is, network programming, TCP, UDP, that sort of stuff. Embedded systems design and interfacing. So, these little microprocessors, we sort of program them, make devices with them, sensors, actuators, that sort of stuff. Embedded C, basically. And the software process. So this one looks like sort of software lifecycle engineering. It's basically like engineering for software engineers, from what I can see, like getting a little bit into project management stuff. Okay, information security, a subject which takes its name so seriously that it is very secure about telling you. Social and mobile computing. Now, I've heard strange things about this. If you were to read the title, you would sort of assume that it's basically like mobile gaming, but then if you read the text, it's a bit like social studies applied to computing. Right, advanced database systems. Okay, And then, yeah, cloud computing. Look, I'm not always sure what to say because I'm trying to give a summary of each of these topics, but I'm not, like, they're not all my thing. So, cloud computing. If you like cloud computing, here's an option. Okay, so of those undergraduate electives that I just ran through, I can select, none of them or up to 3 of them. Now we have the postgraduate electives, and I can choose none of them or up to 4 of them. And the postgraduate electives are Business Information Systems, Introduction to Software Innovation, High Performance Computing. Now, I actually have done this one. The way this works basically is it's an introduction to like SIMD, multi-threading, and CUDA. And for instance, the main project, okay, so there's a few projects. One of the projects is matrix multiplication. You get we need to multiply 2048 by 2048 size matrices, and we need to do that quickly. And we need to benchmark that, in serial, with SIMD, with multi-threading, OpenMP, and CUDA. That's an example. You do the same thing with a bunch of different techniques, and you need to get it fast enough in order to get a high grade. And then the main project for this is completely open-ended. You pick your own topic that you want to work on, and then you just apply high-performance computing techniques to it and speed it up and do a presentation on that. Reasoning about programs. So this is sort of what I'm taking from this is all the stuff that Rust or Ada or any of those other provable languages do. Is there's all the programs you can make, and then from there there's a subset of programs which can hermetically, mathematically you can prove that they are correct. And this is about how do we do formal proofs in computing. Okay, web information systems basically looks like they're doing PHP, JavaScript. It's all the stuff that people complain, I'm doing a Bachelor of Computer Science. Why can I not, call an API or something? Why can I not make a website? So I guess so that people don't complain, this is all the practical web development stuff. So this stuff here, research course, is not super exciting. There's a number of different options depending on how much research you want to undertake. There's 1 semester options, 1 year options, things like that. Okay, and now on to the big one, which is the core courses. I might speed through this a little bit. Okay, so we've got digital health. Now, confusingly, this is not the health of digital devices, but rather uses for digital technology in healthcare. Okay, compilers and interpreters, advanced algorithms and data structures, machine learning, communication systems, advanced topics in security, computer networks 2, continuing on from the previous, advanced embedded systems, similarly continuing on, software architecture, concurrency, advanced human-computer interaction. What is that? I'm actually not getting anything from this description. I don't know, does this sound like fun? Does this sound like a fun thing? Participation in a debate. Critiquing human-computer interaction theories. I would love to see a debate in something like any other programming course. I think that would be pretty fun, actually. But I feel like this is overly theoretical. Well, anyway, it's not... Spoiler alert, it's not something I was going to consider anyway. Data mining, okay. Advanced techniques for high-dimensional data. Information retrieval and web search. Social media analytics, we can leave that one right there. And then there are these special topic courses. Okay, look, so that was just a brief little overview. What do you guys reckon I'm doing? I hope this video is fun. You get to live vicariously through my little thought process. But okay, I'll cut to the chase straight away. So what I'm doing is I'm doing as much low-level programming as possible. I've already taken algorithms and data structures, so okay, great. No need to take that one. Out of the undergraduate electives, I'm going to be taking operating systems and embedded systems. Out of the postgraduate electives, I'm taking reasoning about programs, the formal proofs course. And then in the research courses, I'm taking the 1-year thesis. I'm just falling down a rabbit hole right now. This is like super confusing. If this is information for students beginning in 2025, then why is it including course codes which will be discontinued in 2025? Like any of these I click through and it says this course will be discontinued from 2025. Why is it in the program? I'll have to work that out later. It's a bit strange. Okay, so continuing. On the core courses, of course, I'm going to be doing compilers and interpreters. I'm going to be doing advanced algorithms and data structures. This is going a little more into dynamic programming, like all that stuff, divide and conquer, all that good stuff. More problem solving. Okay, so the original data structures and algorithms course is more of like, these are the facts, these are the data structures and algorithms. And this course seems to be more about like problem solving with them. Then I'm going to be doing advanced embedded systems and principles of program analysis. So this principles of program analysis is like static analysis, basically, for optimization of compilers or for program verification, I guess, just any sort of static analysis. So I think that's it. I'm losing my train of thought because there's so many planes keep flying over. I have to keep pausing in between recording. So I hope you had fun. Get ready with me, plan my degree. All the best. Hope things are going well. And I will see you again soon. Bye.